Space, the final frontier. For years, scientists have been intrigued by the enigmatic dance of the solar wind, especially the slow solar wind. But now, thanks to groundbreaking data from the Solar Orbiter mission, we are closer than ever to unraveling this cosmic mystery. In 2020, the European Space Agency, in collaboration with NASA, launched the Solar Orbiter. This mission aimed to capture the closest and most detailed images of our sun, and to link the solar wind back to its origins on the sun's surface. The solar wind is a continuous outflow of charged plasma particles from the sun, traveling at hundreds of kilometers per second. The fast solar wind, moving at over 500 kilometers per second, contrasts sharply with the slow solar wind, which travels slower than that. This celestial phenomenon has fascinated scientists for decades. When the solar wind interacts with Earth's atmosphere, it can create the mesmerizing northern lights. However, large plasma releases, known as coronal mass ejections, can pose significant hazards, potentially damaging satellites and communication systems. The sun's corona is divided into regions based on magnetic field lines. The open corona has field lines anchored to the sun at one end, allowing solar material to escape easily, producing the fast solar wind. The closed corona, on the other hand, has field lines connected at both ends, forming bright loops over active regions. Occasionally, these closed magnetic loops break and reconnect, providing a brief window for solar material to escape. This process is believed to be the source of the slow solar wind, especially where the open and closed corona regions meet. Using the advanced instruments onboard Solar Orbiter, scientists have been able to test this theory by measuring the composition of solar wind streams. The instruments analyze the solar activity and match it with the solar wind collected, pinpointing the origin of the slow wind streams. The varying composition of the solar wind measured by Solar Orbiter match the changes in composition across different regions of the corona. This provides strong evidence that the slow solar wind originates from the closed corona through the process of magnetic reconnection. The Solar Orbiter mission is a global collaboration, bringing together scientists and institutions worldwide. With contributions from the University of Michigan, UCL's Mullard Space Science Laboratory, and Paul Sabatier University, the mission's instruments provide unprecedented insights into the solar wind's origin. Among these instruments is the heavy ion sensor, which measures heavy ions in the solar wind, helping scientists determine the wind's origin based on its chemical composition. The electron analyzer system and proton alpha sensor further enhance our understanding of the solar wind's speed and variability. Seeing the data come together to reveal the sources of the slow solar wind is immensely gratifying. It showcases the hard work of teams who spent over a decade designing and preparing these sensors. As the Solar Orbiter continues its mission, scientists are eager to analyze more data and compare findings with other missions like NASA's Parker Solar Probe. Each discovery brings us closer to understanding the sun's influence on our solar system.